Okay, there we go. So if you go under week 7 and go under view, you will see at the bottom that I have one more example that I have included in here. And this is, problem number 7 from 11.1, because that's actually not the problem that we will be talking about today. So you do have this another example here under the view videos that you can take a look at. But the example that we are looking at is, let's get rid of this older information here. Okay, is actually 11.119. And when it has that little T next to it, it actually means they're talking about technology. This one is 15, 17, 19, there we go. Alrighty, so this one over here, as you can see, is talking about, let's make this guy a little bit bigger. In 1949, an organization surveyed 1,100 adults and asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? So out of those 1,100 adults surveyed, 352 indicated that they were total abstainers. So this was from 1949. Here we're saying in a recent survey, the same question was asked of another group of 1,100 adults, and 286 indicated that they were total abstainers. So this one here, again, we are still working on hypotheses testing, but, we're getting into more of, working with samples and population, and so a little bit different from what we did in chapter 10 last week. So you can see the first part they're just asking us is to determine the sample proportion for each of our samples. So obviously you can see from 1949 we had 352 people that said they were total abstainers, and then in a recent survey we had 286. So if you look at this, where did that go? Oh, it's right here. Let me go ahead and share this link with you guys again. You will need to make a copy of this because you just have viewing permission. You will not be able to make any changes, but you should be able to go ahead and make a copy of this so you can kind of work along with me if you like. So X1, N1, you can think of, being from 1949 or the first survey they did, and X2, N2, you can think of this as being from the recent survey. So we know for both groups, they did 1,100 adults as part of the survey. So that's going to be our N1, N2 values. Now for X1, they told us that 352 people indicated that they were total abstainers. So the 352 will of course become our X1 value. And then for X2, that will be from our recent survey where we had 286 people say they were total abstainers. So that's the 286 from there. So again, for your sample proportion, you can see it's a simple calculation, X1 divided by N1, X2 divided by N2. So this will give us, just an approximate idea of what proportion of people said, they were total abstainers from alcoholic beverages. So very simple, X1 divided by N1. And again, you can see I'm just clicking on the cells. So that way, when you guys do your calculation, you can do that. And if anything changes, you don't have to go back and redo the calculation. Same thing for sample proportion 2. We'll do X2 divided by N2. And you can definitely see there is a change in the proportion here, right? We went from about 32% to 26% of people who do not consume alcoholic beverages. So let's go ahead and put that information in here. They're asking us to round this to 3 decimal places. So that's 32 and 26 in decimal, so 0.320 and 0.260. And you can see they are telling us to put the 1949 survey first and then the recent survey. So that's the order in which you're entering your answers here. And then, of course, we have to check and see if we are actually able to do a hypothesis testing or not, what kind of sample do we have? So here they're saying, has the proportion of adults who totally abstain from alcohol changed? Use the alpha as 0.10 level of significance. But first, we have to obviously verify the model requirements. So one of the first things we have to do is, in this case, we can obviously make the assumption that our samples are independent because there's really no reason to think, the same group of people from 1949 would be the ones in the recent survey. So that's actually an assumption we are making, that the two samples are independent. So remember, that's one of the requirements. The other one would be we have to make sure that our sample size is less than or equal to 5% of the population size. So you can see that will be the sample size is less than 5% of the population size. So we'll make that assumption. Now for the next one is actually this option B over here, where we have to make sure when we multiply N1 P hat 1 minus times 1 minus P hat 1, and same thing with the N2 P2, we have to make sure that these numbers are greater than or at least equal to 10. So that's kind of where this calculation comes into play. So again, we'll just use our little built-in functions or cells over here. So we're taking N1, multiplying that with P hat 1, which is this 32% that we just calculated here. Multiply that, and I'll put this in parentheses, 1 minus P hat 1. And obviously that number came out to be larger than 10. Same thing for sample 2. So that's going to be N2 multiplied with P hat 2 multiplied with parentheses 1 minus P hat 2, and then close that. And so we're well over 10. So again, that third requirement is also being met. So just make sure you're checking for all 3 of those requirements. And then we'll say check answer over here. That looks good. And now we're ready to get into our hypotheses. So they're basically saying, okay, start out by identifying what your null and alternative hypotheses will be. P1 represents the population from 1949 who were total abstainers. P2, of course, represents the population of adults who were total abstainers from the recent survey. So here the question they're asking you to, and this actually tells us what kind of hypothesis testing we want to do. They are saying, has the proportion of adults who totally abstain from alcohol changed? So when they're using that language, do we use not equal to, do we use greater than or less than? Which symbol do we use in our null and alternative hypotheses? Because that will be a decision you will have to make when you're going through these examples for homework, exam, whatever the case might be. Because you will see they're giving you all 4 of those options: equal to, not equal to, greater than, less than. So when they say, has the proportion of adults who totally abstain from alcohol changed, which symbols do you go for? So remember, H sub 0 is the null hypothesis. H1 is the alternative. So what symbol do we put here and what symbol do we put here? Because we talked about this last week on on whether you use the equal to, not equal to symbol, greater than, less than.
Is it just equal and then does not equal?
Very nice, Cody. Yeah, so when they're talking about has the proportion of adults changed, we don't know if they're talking about has it increased or decreased, because remember when one of the examples we had seen, they had actually said, has your proportion increased or has your proportion decreased? So in that case, you would use the greater than, less than symbol. But when they're just saying changed, change means it could go up, it can go down or whatever, right? They're not being specific. So that's why you use the equal to and not equal to symbols over here. Very nice, Cody. So we will say, of course, with null hypotheses, we would say, well, the proportion hasn't changed and it's the same. So that's the equal to. And then the alternative is where we would say, hey, maybe it has changed. So those are the two symbols we're going with. Again, you'll have to check your answer at this point. Now we are ready to find the test statistic. So what I have done is I'm actually giving you two options to find that. I'm going to show both of them, and obviously you pick what you like. So part of the test statistic, which is this big formula down here, is you will see we just have a p hat option, not p hat 1 or p hat 2. And that p hat comes from right over here, this formula. So let's go ahead and calculate that. Since you are adding x1, x2 in the numerator and n1, n2 in the denominator, we're actually going to put that in parentheses. So I'm typing in parentheses divided by parentheses, and then in the numerator, we'll do x1 plus x2. So that's again right over here, x1 plus x2. And I'm just again using the cells to do that. And then for the denominator parentheses, we'll be typing in n1 plus n2. So that's going to be n1 plus n2. So this will calculate our p hat value. And now we can go ahead and calculate the test statistics. So again, since we are doing p hat 1 minus p hat 2 on the numerator, we'll put that in parentheses, divided by, and we'll do parentheses actually again for the denominator. So in the numerator, p hat 1 is the 0.32 that we calculated here, minus p hat 2, which is the 0.26. And then on the denominator side, you can see we start out with square root. So that's, capital. So we're going to put the square root value in parentheses, and you are doing square root of p hat, which is the number we just calculated, the 0.2900, multiplied by, in parentheses again, 1 minus p hat. Okay, so that's the first square root. Oh, didn't mean to change that. Okay, so I'm going to come outside of the first parentheses. I'm actually going to come outside of the second parentheses because that closes the square root, and then we multiply by square root again, and that's going to have its own parentheses. And in this square root, you can see we are doing 1 divided by n1 plus 1 divided by n2. So 1 divided by n1 plus 1 divided by n2. That will be in the second square root. Then you close everything out, and that will give you your calculation. So you can see, again, we have used cells to type this in. We haven't typed a single number in here. So what happens when you do that is now, if our n value was going to change, let's say this becomes 1200, you can see all those calculations will automatically change. And that's the reason why, we try and stick with using the cells instead of actually typing the numbers in. So you can see our test statistic value is coming out to be 16.5387678. So that's one way of doing this. And if you use the document as I have it right now, literally, guys, the only thing you will have to do at this point is just change these 4 numbers. And if your n1, n2 stays at 1100, you may just have to change x1, x2, and the rest, everything will calculate on its own. So this is one option. The other one is using StatCrunch. And if you go under get more help, under your homework assignment, you will see you do have that StatCrunch option now. So it does show up for these later chapters. Sometimes it has us log in, which technically you don't really have a login. You may just have to refresh the page to get to that part. And for that, again, in the Excel Google file here, you will see I've kind of given you the steps on how to get there. So obviously the first step is opening StatCrunch. Then you go under the stat option, then proportion stats. So let me show you that. So you will see on the top, you have the stat option, proportion stats, and then you have a 1 sample or 2 sample. So this one obviously is 2 sample, right? Because you have the 1949 and then the recent survey. So that's the 2 samples. And then from there, you are going with data or with summary. We don't have the raw data. They haven't told us each individual person's answer. So what we have is the summary. So that's kind of what this means. So start with StatCrunch, stat, proportion stats, 2 samples, and then with summary, which will bring you to this phase over here. So sample 1, and let me see if I can keep my little table over here. So you can see our X1 value was 352. So that's going to go with number of success. Number of observations is, of course, the number of people in the survey, which was 1,100. The recent survey, we had 286 people who abstained and a total of 1,100. So that's your number of successes, number of observations. Of course, we are doing this as a hypothesis test, not a confidence interval. So you will see how these guys have P1 minus P2 equals 0. This is just another way of writing your hypotheses testing. So you will see in my math lab or my stat lab, we had P1 equals P2. And then for the alternative one, which they're using A, but we use 1, we had P1 not equal to P2. This is actually the same thing. So when they say for this guy here, P1 minus P2 equals 0, well, think about it. If I just add that P2 and move it to the other side, I will in fact end up with P1 equals P2, which is what we had in my stat lab. Same thing's obviously going to happen with the alternative. The only difference is this guy now becomes not equal to, but you still have the same thing. So this is just a different way of writing out your hypotheses testing. So don't get confused in that notation. Like I said, different textbooks kind of deal with them differently, and StatCrunch is going with one of those alternative modes of writing. So we've already got our hypotheses test taken care of. I'm not really sure we need to change that significance here because that's not really coming into play at this point. So we just go ahead. Do I want to click on? We're not really graphing anything. So I think we can just go ahead and say compute. And you can see it does some of those calculations for us. Why is their Z value so different from ours? Did I mess up my calculation here? I probably did that. Because I know I kept using my right key and I think that kind of messed things up. Okay. I think one of the problems I'm seeing is right here. So I had P had 1. And yeah, I changed this guy. That should be P had 2. And then we did square root of P hat, which is this number here. And then square root 1 minus P hat. So that guy is okay. Then square root of 1 divided by N1 and 1 divided. Okay, so it was my P hat 2 that I had miscalculated. So yeah, you can see it came out to be 3.10101. And looking at our StatCrunch number, let's see if we can move him. You can see this number does in fact match the one we got from our Google Sheets. So you will see it's again giving you that null hypotheses P1 minus P2 that we're trying to verify. Our sample 1, sample 2 values, your sample difference, which is actually the difference between your sample proportions. If you did the difference between these two sample proportions over here, that's what you would end up getting. That's the sample difference. Standard error, which we didn't really calculate that, then your Z value, and then your P value. And we will actually, you will see some examples where they have you working with this P value also. So you can see you actually get to calculate that P value if you use the StatCrunch. And that's kind of what I lean towards, is because, you know, StatCrunch, you can see you're just having to type in some of those basic values, your two samples in this case, and then, you know, it does all the remaining calculations for you. So use whichever one you are more comfortable with. And then this is where you are typing in that test statistics, which is that Z stat that they're talking about. So it was 3.101, and they only want 2 decimal places. So we should be able to just type in 3.10. So let's check that. Okay. Now, this is where they're asking you for the p-value. And for the p-value, you know, definitely, because the formula is kind of a little interesting when I look at the textbook version. So that's why I kind of always stick with StatCrunch for this. So, you know, calculate your test statistic and the p-value right over here. So 0.0019, 0.0019, but they only want 3 decimal places. So this will actually become 0.002. And now we kind of have to make sense of what the p-value actually tells us. So what we're basically saying is, if the population proportions are blank, equal or not equal, one would expect the sample proportion, the sample difference proportion to be greater than, smaller than, greater than, you know, the absolute value of whatever you are observing from the p-value. So what this basically says, that if your two population proportions are equal, which comes from, remember the population proportion we're talking about is the people in 1949 who said they were total abstainers, and the people in the recent survey who said they were total abstainers. So those are the population proportions we are comparing. So basically we're saying if the two population proportions are equal, then one would expect the sample difference proportion. And what do you think? Should this be greater than or smaller than? And I would probably go with the absolute value in this case, because, you know, obviously these proportions can be on positive or negative side of things. So if your two sample proportions are equal, one would expect the sample difference proportion. Let's go with greater than for now. Greater than the absolute value of the one observed in about, and this is where your p-value is going to come into play, because you can see they're talking about, I'm going to put some number over here, which will be rounded to the nearest integer. So we're saying it's going to be greater than the absolute value of one observed in about blank out of 100 repetitions. So if you look at 0.002, that is technically 2 out of, and this is in the third decimal place, which means you will have 3 zeros over here. So the idea is, if we're going to be doing this out of 100 repetitions, well, out of 100 repetitions means you're only looking at the first 2 decimal places, and that is going to be 0 out of 100. So you're actually going to be typing in a 0 over here, and that is going to depend on, oh, why is this guy not letting me type in? There we go. Not sure why I was doing that. So what we're basically saying is, if your two sample population proportions were equal, we would expect a sample difference proportion, which would be greater than the absolute value if you observed 0 out of 100 repetitions. So it basically means we're not really getting a good result over here, because if you're doing 0 out of 100 repetitions, well, what does that really help you with then? So obviously that means we're going to have to reject our hypotheses, the null hypotheses over here. So that leaves you with options A or C, and you have to decide, and let's make this a little bit larger. You have to decide if you basically have sufficient evidence or you don't have enough evidence. Because remember, the null hypothesis is where we are saying that your two proportions are equal to each other. But because of what our p-value came out to be and how we interpreted our p-value, where you're getting 0 out of 100 repetitions, well, we know our null hypotheses will not stand true. So since we are rejecting the null hypotheses, the question is, do you have sufficient evidence or do you not have sufficient evidence that your sample proportion has changed from 1949 to now, or basically your people who abstain from alcohol has changed from 1949 to the recent survey? Do we have enough evidence or do we not have enough evidence?
We do have enough evidence.
Yes, we do, because you can see that your sample difference yeah, it's still open. You can see our sample difference here is showing us that there is a 6% difference from the 1949 survey we conducted to the recent one. So yeah, there is sufficient evidence. And another thing I wanted to point out is, let's go ahead and select that for one. Let's clear all this out. The other thing you should also keep in mind when you're deciding if you will be rejecting or not rejecting the null hypotheses is if your p-value comes out to be less than your level of significance. Where was our level of significance? There we go. Our level of significance was 0.10, and that is where that level of significance comes into play. Our p-value was 0.002. So when your p-value is less than your level of significance, reject your null hypotheses. And you can see that makes sense, because that is also the reason why this guy came out to be 0, because in the 100th place, we have a 0 over here. So as you can see, guys, there's really not like a huge calculation aspect to this problem. You know, one of the initial calculations you did were the sample proportions at the top, and then we did our little checking here with the N1, P1, 1 minus P1, and then N2, P2, 1 minus P2 calculations. And then really the big calculation comes down with your test statistic and the p-value. And again, if you're using StatCrunch for that, you know, there's not a whole lot of calculation involved in this case. And for the p-value, I definitely recommend using the StatCrunch. You know, the test statistic, we were still able to calculate here in Google Sheets, but we cannot do that with the p-value. So in this case, your best option is the StatCrunch over here. All right, let's see. Do you guys have any questions for this example here? All righty, another one that I had was this guy over here. So this one is saying a survey asked, how many tattoos do you currently have on your body? Out of the 1244 males surveyed, 195 responded that they had at least one tattoo. Out of the 1,022 females surveyed, 148 responded that they had at least one tattoo. This one, you can see they're asking us to construct a 95% confidence interval to judge whether the proportion of males that have at least one tattoo differs significantly from the proportion of females who have at least one tattoo, and then of course interpret that interval. So again, you can see they're saying let P1 represent the proportion of males with tattoos, P2 would represent the proportion of females with tattoo, and then they're asking us to find the 95% confidence interval. So for this guy also, we are actually going to use StatCrunch to help us out because you're comparing two different groups of people over here. So let's get rid of that. You're again going to stat. Now I'm pretty sure we go 2 samples with summary. So basically the same route that you took over here for this example, you're taking that same summary route with this example over here. So number of successes. So for the males, we'll call that as our sample one. We had 195 out of the 1244 males. And then for females, we had 148 out of our sample of 1022. This one, however, is a confidence interval. So go from the hypothesis test to confidence interval. They, of course, told us to do this as a 95%, which you will see is the default that is set up for you. Now, for any reason, if this number changes, they didn't have 95% and they had, let's say 90% or 99%, you can see once you click on that confidence interval, you are actually able to change your level of confidence. So just make sure you do have the correct level of confidence over here, and then just click on compute. So again, just type in those 4 values, make sure your confidence interval value is correct, and it does the calculation for us. So again, P1 minus P2, we've got our 4 values. You have your sample difference, standard error, lower limit, and upper limit. And that's what they're asking us here, is to find the lower bound and the upper bound. So this guy will be, let's see, 3 decimal places. So lower bound would be negative 0. Let's see, 1, 2, 3, 4. So 0, 1, 7, 6 will become 1018. And then for the upper bound, again, you have 0.0414, so it will just stay at 041. So 3 decimal places. Let's type that in here, negative 0.018, 0.041. Okay, and this is kind of weird. I don't know why this problem does that, but after you check your answer, it has you click on continue. All righty, so this is where we are doing an interpretation. They are saying, okay, there is a 95% probability, there is a 95% confidence. So which one do you even start out with? Do we do a probability or a confidence?
Confidence.
Yeah, because remember, this was a 95% confidence interval. So again, it's that, they're making sure you know what you're doing here. So it's got to be options C or D. So let's look at the difference over here. We are saying there is a 95% confidence that the difference of the proportions is in the interval. Conclude that there is insufficient evidence of the significant difference of the proportion of males and females that have at least one tattoo. The part D is saying there is 95% confidence that the difference of proportions is in the interval. Conclude that there is significant difference in the proportion of males and females that have at least one tattoo. So basically it comes down to, do you think you have enough evidence to support that there is a difference between the two, parties involved over here, or there is not enough evidence? So let's come back to our StatCrunch over here. So this was the data from the 2 groups. The first 2 are for the males, the second 2 are for the females. If you look at the sample difference, this is telling you, if you did 195 over 1244, and 148 out of 122, what the difference between these two proportions would be. And then your standard error, and then our upper and lower limit. So the idea is, how confident are we that we have sufficient evidence to say, yes, there is a difference in the proportions and there is enough evidence to support it, or no, there is not enough evidence to support it. And I would say, look at your sample difference, look at your interval, and what would you say? Is there a significant difference in the proportions of male and female who say that they have at least one tattoo? Okay, Cody, I see you're saying no. Anybody else? What are you leaning with? Is it option C or option D? So if you look at that sample difference right over here, you have 0.011, which is approximately 1%. If you move that decimal over, 1% is still a slightly small number that you are looking at in terms of, the difference between the proportions. So not a whole lot of difference, between our two parties over here. So in this case, I would actually go with, I'm leaning more towards there's insufficient evidence that there's a big difference between the sample proportions. And remember, this is just coming from one sample, right? If we had to keep doing this, we would then have to see, are we seeing that increase happening or not? So just with the one sample that they gave us here for the males and females, no, we don't have enough to support our decision over here. So that's kind of where, the confidence testing is coming into play. So in this case, you are basically comparing two groups of data. It can be like we saw in this example, where you had males and females, or like we saw in the previous example, where you had, time difference from 1949 to a recent survey over here. So that's kind of how these problems are working out to be. So these were the two examples from chapter 11. And then, like I said, remember you have that one example under the video view option that you can take a look at. Now, for chapter 4, we're probably not going to have too much time to do multiple examples, but I did want to show you at least one example. Maybe from the first section. I'm not sure if I'll be able to do one from the second section. This chapter, kind of goes into a little bit of a different direction, because this is the one where, we do the correlation. Oh my God, I'm not having a good day today. Again, that word just slipped out of my mind. I know we talk about correlation. Oh my God, scatter diagram. Sorry, there I go. So this is where we kind of actually are doing comparison again between two data sets. And, we're trying to decide, what kind of data sets they are, if there is any correlation between them or they are completely separate. So we talk about the correlation coefficient and those kind of things. So the one example I wanted to show you is actually number 14. And this is a little bit of a longer problem, and that's the reason why I selected this, because you kind of get to see a good working of how these scatter diagrams and correlation coefficients come into play. So this one is talking about a pediatrician wants to determine the relation that may exist between a child's height and head circumference. So she randomly selects 8 children from her practice, measures their height and head circumference, and obtains the data below. So you can see those values there. And then they're asking us to, see, okay, what conclusions can we draw from that? So if the pediatrician wants to use height to predict the head circumference, determine which is the explanatory variable and which one is the response variable. So in this case, as you can see, they are talking about how she wants to use, or he wants, well, she wants to use the height to predict the head circumference. That actually means your height will become the explanatory variable and the head circumference will become the response variable, because she wants to say that the height is what determines the head circumference. So that's why the height is the explanatory and the other one is the response. Okay, now we have to actually come down to our scatter diagram, and you can do this using Excel, and in Excel you basically copy over your data. So if you want to open this in Excel, okay, while it's trying to open, we can also do this in StatCrunch. So here, looks like we're in Excel right now. Select your data table. So, once you hit open, and then you are going to go under, let's see, Excel. We go under Insert and look for scatter diagram, which should be this guy, I believe. And I think I just used scatter. And it gives you a general idea of what this looks like. Sometimes you might have to, adjust your lower limit and upper limit. You may have to adjust your values on this, but looks like 1, 2, 3, 4, 5, 6. I think there might be some repetition in our values over here, but it kind of gives you an idea of what that scatter diagram looks like. If you wanted to do this in StatCrunch, then in StatCrunch also, go ahead and select your data. So go ahead and select the entire 2 columns. And then you are going to go under Graph and Scatter Plot. There you are. And then here, you're going to choose your X variable as the height, Y variable as the head circumference. And remember, we selected the height as the explanatory variable. That's why that's going on the X variable. And I imagine that's pretty much it. Then you go under your graph properties down here. And I think what I did was check mark the horizontal lines and the vertical lines so that I could actually see where our points are going to fall and just compute. This one, you may kind of have to adjust it a little bit. So let's see, I think I'm just going to start this at 25 and go up to maybe 29. And you can do the same thing with the y-axis. Let's see, what did that data look like? Probably go from like 16.9 to 17.5. So it gives you a little bit of a better idea of what those look like. But you can kind of see the general shape that you are looking for is going to be right here on the bottom. You have these 2 points that kind of fall vertically together. Then you have a grouping of these 3 points here and then that 1 single point over there. So that is what you are looking for when you have to select your scatter plot over here. And looking at that general direction that we have, option B is looking good, or option D is looking good. And this is where you really want to make sure these horizontal lines that you are seeing, they are matching with the values that you have. The other thing you can do, and you can kind of make that adjustment in StatCrunch really well, is you can see how these guys are going from 16.9 to 17.6, and then from 25 to 28. So you can actually make those adjustments over here. So on the y-axis, let's take this guy from, what was that number, 17.6. So let's change this to 17.6 from 16.9. And then on the x-axis, you're going from 27, I think they had 28. And then that'll give you a little bit of a better idea. So you can see right at 17 is where we have this first dot over here, and then right at 17.2, 17.4. So you can try and match that with this over here. So, you know, let's see, you're going from 16.9. So that should be 17, 17.1, 17.2, 0.3, 17.4, 17.5, and then 17.6. So you can definitely see this is not the guy because you have 17 and 17. No, actually this one will fall at 17.1, isn't it? So 17, 17.1, and then 17.2, 17.3, and 17.4. And that's exactly what this guy looks like. So 17, 17, 1, 2, 3, 4. So this one was graph D, I believe. And if you look at graph B, are these the same graphs, B and D?
The X and Y axis have swapped.
Yeah, because this guy, if you look at vertically with the x-axis, this is on 28, 27, and this would be at 25, 75, 26, 75. So yeah, because this guy here would be 26, this would be 27, and these would be, you know, 0.5 in the middle.
What I mean is like height is on the x-axis, and then the circumference is on the y, and those are different between B and D.
Oh, I see what you're saying. Okay, yeah, sorry, I didn't even think about that. So yeah, your height is here and circumference for the head is here. And you're right, on D, these are switched around. Thank you, Cody, for that. So yeah, watch your labels, I guess. So that, and see, and that was the one thing that I kept thinking about, you know, why do they have the points in the same place? And then I'm glad Cody noticed that your two labels were interchanged. So that will of course make us go to graph B then, because that's where your labels were correctly identified. So once you have your graph selected, you can also actually use Google Sheets to try and come up with your scatter plot. But you know, if you're going to be using StatCrunch, then obviously stay with StatCrunch for this. Now for your correlation coefficient, again, I'll show you this using StatCrunch again. So for this guy, you will go under, let's close this. You will go under Stat and Summary Stats, and you see where it says correlation. You will go over there. Now, using the Control key on your keyboard, go ahead and select both of these because we, of course, need both the columns in there. And then, honestly, once you select both of them, just go ahead and hit Compute, and you will see it shows you what your correlation is between your height and head circumference. And this guy is coming out to be, how many decimal places did they want? 3 decimal places. So this will come out to be 0.8857. So that's 0.886. Okay, so let's type that in. 0.886. I'm not sure why it keeps doing that to me. 0.886. All right, let's check that guy. Okay, now if you guys have not had a chance to look through chapter 4 yet, you know, the correlation coefficient value tells us actually a lot about If our values are positively, associated, negatively associated. So the idea is the closer you are to +1, because the value of R, the correlation coefficient, can go anywhere from -1 to 0, 0 to +1. So the closer you are to 1, we're saying there's a positive correlation. The closer you are to -1, we would say that's a negative correlation. And the closer you are to 0, of course, we would say there's really not a whole lot of correlation because you're kind of scattered all over the place. So in this case, what's happening is, let's go ahead and click on that graph for one more time. Because, if you'll see that a lot of times, they talk about drawing a straight line through the scatter plot. And the idea is how close you are to that line over here. If they're very, very close, like the distance between the points is not too far out, they kind of balance each other out. We would say you have a positive correlation. If you are badly scattered, then of course we would say, well, there's really not a whole lot of correlation. So this one is saying, does a linear relation exist between the height and the head circumference? And in this case, we would say yes, definitely. So the two yes options are A and C. This one is saying yes, the variables height and head circumference are positively associated because R is positive and the absolute value of the correlation coefficient is greater than the critical value. The other one is saying yes, the variables height and circumference are positively associated because R is negative and the absolute value of the correlation coefficient greater than the critical. Obviously, our R value is not negative, so you are going with this one over here. Okay, and then let's see our critical value. Oh, I'm trying to remember, how did we come up with the critical value? Okay, is our N is equal to 8. Yeah, Hillary, go ahead and ask your question. And I'm trying to remember how I came up with the critical value over here.
So I just had a quick question. Is there any way the take-home exam could be opened on Tuesday or no?
So if I open it on Tuesday, then you will have till Wednesday midnight to take it because you get 48 hours
Okay,
to take the exam. So if you needed me to open it sooner, I can definitely do that.
okay, got it. Thank you.
So do you want to think about it and let me know?
Yes, I'll think about it and let you know.
Okay, not a problem.
Thank you.
Yeah, you're welcome. I am completely drawing a blank over here. How did I calculate? I know I calculated it using one of this technology. Okay, we might have to look at our table over here. Because let's see, we have 8 kids that the doctor used in her study. And there we go. With our N value of 8, your critical number or critical value is 0.707. Okay, so let's go ahead and close this. 0.707. Okay, so what this one here is basically saying is that if your R value is positive and the absolute value of the correlation coefficient is greater than your critical value. So of course you can see 0.886 is going to be greater than 0.707. So again, you can see we're talking about that positive correlation between the height and the head circumference. Now this one over here actually kind of goes through and repeats the same calculations. What they're having you do is basically convert the calculations from inches to centimeters, and they will have you repeat the correlation coefficient to see will your correlation coefficient change if you go from inches to centimeters. So you can see they're giving you the conversion over here. They're saying, you know, go and use this conversion of 1 inch is 2.54 centimeters. So in this case, you can use, again, StatCrunch, Excel, where's my Excel? To try and come up with these. So basically what I did for these guys was just, you know, click on the cell and multiply it with 2.54. And then I basically just did that for all of these guys. So this is A3, A4, A5, which should go all the way to A9. So all of these. So we don't need this. This should be the last one because that will be for A9. And then you can repeat that on the other side for the height. So this will be B2 times 2.54, and then just bring that down. Okay, so this is now in centimeters. I'm not sure if it will let us copy and paste this over here. You might have to do it individually. And then I bring that data over here to StatCrunch and just repeat. So you can do for the correlation coefficient, again, go under stats, summary stats, and correlation. Remember, use the control key to select both of these and click on compute. Oh, that number should not have changed. What did I change here? Because, you know, the idea is the correlation has to come out to be the same, even if you change it from inches to centimeters. So, well, these numbers look good. A4, A5, A6, A7, A9. B2, B3, 4, 5, 6, 7, 8, 9. And that's what we copied over here, unless we need to change this. Yeah, but that shouldn't make a difference if you have 3 decimal places or 2 decimal places or 1. Well, let's see what this guy tells us here. So they want us to type integers or decimals. They're saying do not round your answer. Okay, let's see what happens. Okay, check that. That looks good. And they'll have you type the remaining 4. I'm not sure why they didn't just give you one big table with all the answers, but I guess, you know, in case if you had any calculation errors, you wouldn't have to start over. Okay. And you can see, you know, once you do these calculations in your Excel, you know, obviously, like I said, you can use Google Sheets for the same. Okay, let's go ahead and check that. So you can see our numbers are correct. And they're having us calculate the new linear coefficient R, which this guy seems to be giving us. I know what happened because I used height and circumference, and it's actually using the entire column. So it's using the first 8 and the last 8 calculations. So let's move it to variable 4 and 5. And let's repeat that calculation. So correlation, variable 4 and 5, and hopefully we should get, there we go. So that's what was happening because I kept it in the same column as height and circumference. It was using all 16 numbers instead of just the 8 I had selected. So you can see this guy is again coming out to be 0.886, which is what we had over here. And we would say had no effect on R, which is exactly what you should expect, because just changing it from inches to centimeters should not change what kind of a correlation you have between your height and head circumference. So you can see here we had 0.886, and that's the same value we got once we converted it to centimeters and recalculated it, 0.886. So that is exactly what we should have expected to see. So just keep that in mind, even though you are changing the mode from the standard measurement system to metric, it should not make a difference in your correlation coefficient. So questions on this one over here, guys? So I will actually share with you the videos that I created last semester from problems for sections 4.1 and 4.2, because you do actually have a couple of these really long problems in these 2 chapters, where they go through these multiple types of steps to calculate. So I will share those videos with you. They will either be under the view section that you see over here. So if you go under week 7, I will either post them right here under the interactive session, and you can see I've kind of had these from last time. I might go and check if these links are active or not. I'm not sure about them, or I will post them under the week 7 view section over here. So just look for those under one of these 2 sections to find the videos on 4.1 and 4.2. And of course, if you guys come across something you need extra help, don't hesitate to reach out. And very quickly before I let you go, let me share this link with you, which is the Google Sheets for Chapter 4 example. So make sure you go ahead and make a copy of these also. So you'll see through chat the link come through for Chapter 4 example. So go ahead and make a copy of this, and you will see there are multiple different examples that I have in there from sections 4.1 and 4.2. So you might find that helpful as you're going through those homeworks. So just as a final reminder, guys, if you are going to be retaking any one of the older chapter exams, please send me an email before Friday, letting me know which chapter you want to retake, and I'll set that up for you. And then I will be seeing you guys next Wednesday to take our in-class version of the final exam. So if you want to ask any questions, please stick around. I'll be happy to answer them for you. And if not, then I will see you guys next Wednesday. So have a wonderful day, guys. Be careful, stay safe, and I'll see you next week. Take care, everyone. Be careful.
Thank you.
Thank you. Bye, guys.
Can I ask a quick question?
Yeah, sure.
How did you find the critical value again? Like in
So
stack?
the critical value is actually available in that table. So let me very quickly share my screen here. So right here, Samuel, you'll see that they have the little table for the critical values, and this is based on your size of your sample. So since they told us over here that she selected 8 children from her practice, you are looking at n equals 8, and then based on that, you select the critical value.
Okay, all right, that makes sense.
Okay, very good.
Thank you.
Thank you. Hey, Sky.
I know you answered some of these questions in class, but I was having some issues with my computer. So just to confirm, for the test, we are allowed to use stuff like Desmos? Because I remember I asked you like in the beginning, but I can't remember if you were going to decide to not do that or, sorry.
Yeah, so I'm okay with Desmos. So you can use Google Sheets, Excel, StatCrunch. If you want to use Desmos for any other calculations, you can. You have access to your notes, the formula sheets that I've shared with you. So as I've been telling your classmates, the idea was, make sure the work you are doing is your own. But if you're
Mhm.
having to use technology to support you, I'm okay with that.
Okay, so I'm assuming that would also mean we're also allowed to use like to write stuff down as we're like working, if it is easier for us to write down like an equation or something to think it through better, if that makes sense.
Yes, like, are you talking about using
Scratch paper, yeah.
Yeah, that's fine, totally fine.
Okay, sorry. I had like a whole little list of all the questions that I wanted to make sure I'm allowed to do before I just jump into. So do you have like a set number of how many questions are going to be on the test yet, or because I saw on grades that we have 24, but I wasn't sure if that was going to change or if this was still going to be 24.
Let me confirm that for you very quickly. Okay, so on the in-class version, yes, you do have 24 questions. And then on the take home, I think that one actually, because it has longer questions, has only 20 questions on it.
Mhm. Okay.
So yeah, the in-class has 24 and then the take home has 20.
How would you think like the breakup of the material we've had so far is going to be in both of the tests, if that makes sense?
So both of the tests actually do go from chapter 1 to 11.
Mhm.
But on the in-class version, because like I was saying earlier, since we only have 1 hour of time, dedicated to it, a lot of those questions are going to be like, the terminology and the concept quizzes you guys did for each chapter, plus some of the basic questions where you don't have too many multiple steps to get through. Because, since I wanted it to be just a 1 hour test, but we were still going through the entire list of chapters, a lot of them are going to be simpler questions. Whereas on the take home one, since you guys are at home and I'm giving you a longer time to work on it, on that one, you will actually have more of like the questions we worked on today, where you have those multiple steps, you have to go through different calculations to move forward. So those type of questions will be on the take home, and then in the in-class, it will be something that you can answer in just a couple minutes or a few seconds instead of taking 10 minutes to solve one problem.
Okay.
They will both be going from chapters 1 through 11.
Okay. So is the 9th our like last day in class, like our last Zoom call with you?
Yes. Because what's happening is it's kind of weird the way they designed this class. So I believe the official last day is the 10th, which is when your take home final is due. We go on spring break, and then they gave us 2 additional days, Monday and Tuesday of that week. But we don't meet on Monday or Tuesday, so it's not technically class day for us. So that's why we're wrapping up our class on March 10th instead of having you guys wait till the 21st, 22nd to wrap it up, which was so weird that they gave us those 2 days after spring break. I'm not sure what the thought process was. But for us, the last class meeting is March 9th, and then March 10th is when you guys are submitting your take-home final.
Okay. So the take-home final, essentially, let's say like after class, we all send you an email for the password for it, and it just appears on like our,
Yes.
I forgot the program for all of our
Yes.
homeworks and
So
stuff.
my stat lab, it will actually open up on midnight of the 9th. So I've set it up where it will open up on March 9th at 12 a.m. and it will close on March 10th at 11:59 p.m. So that gives you that full 48 hours, and you can, take it if you want to do it on the 9th after you do the in-class version, you can take it then. If you want to wait till the 10th to take it, so I've kind of left it open to you guys. That way, whatever time is more convenient, you can give yourself that 3-hour time period. So you're not feeling rushed or having to run to some other, class or job or whatever. So that way you can pick your own time when you want to take that take home final.
Okay, so no asking you for a password whatsoever.
There is a password for the take home, and kind of like you do for exams right now, you can request that, a week in advance. You don't have to wait till the 9th to ask for it, but like you said, it will not show up on your list till the 9th actually.
Okay. Okay, thank you. I think that's the last question I have.
And if something else comes up, you think of anything else, don't hesitate to email me, and I'll be happy to answer any questions you have.
Okay, thank you. Have a great rest of your day.
You as well. Take care, Sky. Bye-bye.